What if the Earth was once a moon of a larger planet? Imagine waking up one morning to the shocking realization that everything we thought we knew about Earth's origins might be wrong. That Earth wasn't always the grand, independent planet we see today, but something far more humble. A moon. A mere satellite orbiting a much larger, long-lost planet. What if, long before Earth hosted oceans and forests and civilizations, it was just one of many moons circling a massive planetary giantone that has since vanished from the solar system without a trace? This possibility isn't science fiction. It's a bold scientific speculation that challenges the very core of planetary science. It asks us to rethink what it means to be a planet or a moon. And it opens a door into a hidden chapter of our cosmic history, one that could explain many of the mysteries that still surround our planet today. To explore this theory, we first need to reconsider the definitions we've long accepted. We're taught that planets are large bodies orbiting stars, formed from the swirling dust and gas of a protoplanetary disk. Moons, on the other hand, orbit planets, and are often seen as secondary objects, lesser companions. But what if the boundary between planet and moon isn't as clear-cut as we once thought? Across our solar system, we find moons that challenge this divide. Ganymede, a moon of Jupiter, is larger than Mercury. Titan, Saturn's largest moon, has an atmosphere thicker than Earth's and lakes on its surface. These aren't just passive followers, they're active worlds with complex geologies, atmospheres, and possibly even oceans beneath their crusts. So, if moons can be so Earth-like, is it possible that Earth could once have been one of them? Could a world like ours, capable of supporting life, have once orbited a planet even larger than itself? This idea gains strength when we look deeper into Earth's own features. Our planet has some unusual characteristics, especially its density. Earth is the densest planet in the solar system, and its iron core is proportionally larger than expected. Where did all that iron come from? Why is it so concentrated in the center of our world? Geologists have long debated the origin of this feature. Some suggest that early Earth experienced intense collisions that stripped away its outer layers. Others propose a giant impact that caused heavy elements to sink inward. But these are just modos educated guesses. The mystery becomes even more intriguing when we examine the moon. The most accepted theory says the moon was formed when Earth was struck by a Mars-sized object called Theia, and the resulting debris eventually coalesced into our natural satellite. But there's a problem with this theory. The moon's composition is eerily similar to Earth's mantle. Too similar. If most of the moon came from Theia, why does it look chemically identical to Earth? Some scientists argue that the collision was so violent it mixed both bodies completely. But this idea has never fully satisfied the inconsistencies. What if the answer isn't that Earth was struck by Theia, but that Earth itself was once in orbit around a much larger world? Imagine a time billions of years ago, when our young solar system was a violent, chaotic place. Newborn planets formed and migrated across the disk, colliding and reshaping the landscape. Among them was a hypothetical super-Earth, or gas giant. Call it Hypatia, that once orbited closer to the Sun. Around it, several moons spun in gravitational dance. One of them was Earth. At some point, Hypatia may have been destabilized perhaps by gravitational interactions with a migrating Jupiter or a forming Saturn. The result? Hypatia was pulled into the Sun, broken apart in a cataclysmic event, or ejected into interstellar space. Earth, caught in the gravitational chaos, was flung out of orbit, no longer a moon, now a free-floating protoplanet. As Earth spiraled inward toward the Sun, it encountered immense forces, collisions with asteroids, internal heating, and a new orbital path. These disruptions could have reshaped it, completely melting the interior, forming the dense core, and kickstarting the tectonic activity that still drives our planet today. And what about the moon? Perhaps it didn't come from Earth at all. Perhaps it's a sibling fellow former moon of Hypatia that was captured by Earth during this cosmic upheaval. Or maybe it formed from the debris of Hypatia itself. carried along by Earth's new gravitational field. Suddenly, the similarities in composition aren't a mystery, they're the legacy of a shared past. This hypothesis also sheds new light on Earth's tilt and rotation. Our 23.5-degree axial tilt gives us seasons. But how did we get it? One theory says the Theia impact knocked Earth off balance. But if Earth had been flung from orbit around a massive planet, the violence of that ejection could have had a similar effect, causing the tilt, triggering a chaotic spin, and eventually stabilizing into the day-night cycle we experience today. It also offers an explanation for Earth's oddly fast rotation. A newborn planet should spin more slowly, but Earth completes a rotation in just under 24 hours. An escape from a massive planet's gravity might have accelerated its spin, another scar from a forgotten past. The implications don't stop at geology and orbital mechanics. If Earth was once part of a larger planetary system, it may have shared more than just space with its parent. It may have had access to a richer set of material elements, compounds, even organic molecules. If Hypatia had an atmosphere, or a magnetic field, or a moon system with water and organics, Earth could have inherited part of that environment. Could life, or at least its building blocks, have begun while Earth was still a moon? This leads to one of the most exciting possibilities. If Earth developed life-bearing potential early, while still orbiting another planet, then the origin of life might not be tied to a stable sun-orbiting world. It could have started in a more complex gravitational system, with more dynamic conditions, radiation shielding from a giant planet, and periodic heating from tidal forces. In that context, Earth isn't just a special planet, it's a survivor. A world that adapted after being ripped from its home, finding new balance around a star it once merely passed by. If this scenario is true, it has profound implications for how we search for life beyond Earth. Moons, long overlooked in the hunt for habitability, might be prime candidates. Europa, Enceladus, Titanthus, icy satellites of giant planets may be far more promising than we imagined, because if Earth was once a moon, then life doesn't need a stable planet, it needs stability of any kind. It needs opportunity, chemistry, and time, and moons can provide that. It also invites us to re-examine the objects around us. Could fragments of Hypatia still exist in the solar system? Unusual asteroids, unexplained gravitational tugs, or even rogue planets lurking in the Kuiper Belt may hold the key. We might be surrounded by the shattered remains of the planet that once cradled the Earth. Some scientists are already searching for these signs. Isotopic anomalies in meteorites, unusual orbital paths in the outer solar system, strange densities in objects we can't explain. One by one, these clues might converge on a single truth, that something massive once existed, where now there is only emptiness and that we, Earth, are its last living witness. Of course, this theory remains speculative, but it's not without precedent. We've discovered rogue planets drifting through space. We've seen stars consume their own planets. We've observed planetary migration, orbital instability, and system-wide chaos in other star systems. We know the early solar system was violent and unpredictable. So, the idea that Earth's origin was more dramatic than we thought isn't absurd, it's consistent with what we see out there. And if this theory one day proves correct, it changes our place in the cosmos. It tells us that Earth isn't a static product of its environment. It's the result of survival, of transformation, of cosmic evolution on the grandest scale. So, now, imagine the Earth, not as a planet formed in calm and balance, but as a former moon, cast into fire, reshaped by chaos, and reborn as a sanctuary of life. And ask yourself this final question. If Earth was once a moon, then where's its ancient parent now? Still drifting in the darkness of interstellar space? Broken, scattered, forgotten, or perhaps watching us silently from a distance too great for even light to carry its final whisper?